Hello everybody, this lesson is on lines in the Cartesian plane. I will be showing you about the standard and general form of a line, as well as how to find parallel and perpendicular lines using the slope of a line. So first, there are different forms of the linear function that I'm going to show you today. And in fact, there are also different names for those forms depending on where you are in the world. Right now, at this point, you should know y equals ax plus b. In other places, it's y equals mx plus b. Regardless, that a means the same thing. However, this in Quebec forms is called the standard linear equation, and it is the preferred form, especially in this course. Whenever you're given a straight line on a Cartesian plane, this is usually the equation that would go with it, or the form of the equation that would go with it. So just as a recap, for y equals ax plus b, which we call the standard form in this course, our slope is considered a. Like I said, in other places it could be m, and b is considered the y-intercept, also known as the initial value of the function. Usually you are going to be asked to find what's called the x-intercept, also known as the zero. You can find the zero of a function by making y equal to 0 and solving for x, or you can also use a fun little formula where you would just take your b and your a and you would do negative b divided by a, and that would actually give you the x-intercept of the function. This is usually a good way of finding a second point to plot your functions on a graph, in addition to already knowing the y-intercept. We usually go into details of the y-intercept and the x-intercept when we do properties of functions. Right now, though, I am giving you a function on a graph. It is a linear function because it is a straight line, so we know it's first degree. But instead of calling it what you might be used to, I can also tell you that the rule for this line is actually 10x plus 2y minus 12 equals 0. And this is where there are different ways to write a linear function, and that's what I want to talk about. There is something called a general form of a linear function. Now here's the thing. The standard form in Quebec, the y equals ax plus b, we call it standard form. In other places, you might refer to this as the slope-intercept form. Where I am, though, the general form can also be considered the standard form in other parts of the world. But again, for this course, we are calling it the general form. It looks like ax plus by plus c equals 0, where the capitals A, B, and C are actually integers, meaning they are not rational numbers or fractions. We do not allow this in the general form. Some cool formula facts: if you want to find the slope using the general form, you use negative a over b. If you want to find the y-intercept, you do negative c over b. And if you want to find the x-intercept, you do negative c over a. Or what a lot of my students tend to go to is, I'm just going to change it back to standard form by isolating y, and then I can clearly see what my a and my b is, or what my slope and my y-intercept is in that way. So if that is the case, it is considered to be the preferred form for many reasons. Let's try to isolate y in this equation. So it looks like y equals ax plus b. So in this case, we start with 10x plus 2y minus 12 equals to 0, and you bring everything that isn't y over to the other side using addition or subtraction. So I'm going to subtract 10x on both sides and add 12 on both sides to get 2y is equal to negative 10x plus 12. And my last step is to isolate my y by dividing everything by 2, and I get that the standard form of this general equation is y equals negative 5x plus 6. And of course, now you're able to see that the slope is negative 5 and the y-intercept is 6. As a fun little practice, I challenge you to try to put these equations into standard form. Pause this video, and I will show you the answers in a bit. So if you were to put these equations in standard form, these would be the answers you would obtain. And you'll notice that in my answers, I did keep them as fractions. Also, you can use decimals, but I did want to show you that either way, it's okay to have these kinds of numbers in a standard form, but not in a general form. If you were also curious, you could actually change the standard form of a linear function to general form Maybe there are some reasons why you need it. For example, maybe you're trying to solve a systems of equation, which I will also mention in another video. But in order to change a standard form to a general form, your job is to make the equation equal to 0 and to remove any fractions or decimals that there may be in the equation once you've equated it to 0. So in my example, I have y is equal to 0.2x minus 1.4. I'm going to bring my y over to this side over here by subtracting y on both sides. And then my last step is to remove the decimals. I'm actually going to multiply it by 10 because I noticed that if I do multiply it by 10, both of these become whole numbers. And so if I multiply this by 10, I multiply everything by 10, and finally I get 0 is equal to 2x minus 10y minus 14, which is the general form of a linear function. Now, moving on, one of the most important things about slope is it can actually tell you what kind of lines you have. So here are two functions, g and f, and I'm sure you kind of see something similar between them. They are actually very parallel to each other, or they are separated by the same distance from positive to negative infinity, or for all real numbers. Now, if I give you their rules, function f is y equals negative 5x plus 6, and function g is y equals negative 5x plus 2. There's something that you should notice they have in common, which is that they have the same slope. Their slope is negative 5. So the rule is that when two or more functions have the same slope, you automatically know that they are parallel to each other. So for example, here are two linear functions. One is in standard form and the other is in general form. We know that in the standard form that the slope is 2 because our a is 2. In our general form, we can use the equations I gave you in the general form where you could find the slope. However, if we just change this to standard form, you would notice that the slope is 4. And so in this case, the lines are not parallel because they have two different slopes. One is 2 and one is 4. A reciprocal of a number. You must have seen this word when dividing fractions. In this case, you would find the reciprocal of the second fraction, or you would flip the second fraction and then you would multiply. So in this case, you would flip the second fraction and you would get 7 over 4 instead of 4 over 7, and then you would multiply to get 7 over 12. This is called the reciprocal of a number. You take the reciprocal of a number by flipping the fraction. Now, one thing that people always wonder about is what would I do if I have a whole number and I want the reciprocal of a whole number? 3 is actually 3 over 1, which I'm sure you know. So then the reciprocal is actually 1 over 3. And something else that you need to know is a reciprocal is if you take a number and if you multiply it by its reciprocal, it should be equal to 1. So for example, if I do 3 times 1 over 3, I get 3 over 3, which is equal to 1. That's also how you know what a reciprocal is or if the reciprocal is correct. Now, to add on to that, there is something called the negative reciprocal. The negative reciprocal is if you take the reciprocal of a number and you, on top of flipping it, you have to change its sign. So if it originally was a positive number, it would become a negative number and vice versa. For example, if I give you the fraction 3 over 2, the reciprocal is 2 over 3. But if I'm asking you for the negative reciprocal, not only would you flip it, you would also add a negative in front because it used to be a positive. If I were to give you the number negative 4, the reciprocal of 4 is 1 over 4, and because it was a negative, it becomes a positive 1 over 4. So you're flipping it and also you're changing the sign of its number. If I ask you for the negative reciprocal of 5, you would say, well, it's 1 over 5, but because it was positive to begin with, my reciprocal will now become negative. Why is this important? Now, here on a graph, I've given you two linear functions that happen to cross at some form of right angle. This also means that they are perpendicular to each other when you cross at a perfect 90-degree angle. In terms of their slope, I know that there's lines H and J, and I know that they are perpendicular to each other. What exactly does this mean for their rules or their function equations? For line H, The rule is y equals negative 5x plus 6. For line J, you have y equals 1 over 5x plus 6. If you take a closer look at their slopes, a negative 5 and a positive 1 over 5 is actually negative reciprocals of one another. So the slopes of these two perpendicular lines are negative reciprocals of each other, which is the next rule in terms of slopes and perpendicular or parallel lines. Here is a fun activity for you to try. Are these two lines perpendicular to one another? So here I have y equals negative at 1 over 3x plus 9 and y equals 3x plus 1. If you take a look at their slopes, you can see that they are, in fact, perpendicular to one another because their slopes are negative reciprocals from one another. In this example, you have y equals negative 2x plus 9 and y equals 2x plus 9. Now, although their signs are different, the slopes are not negative reciprocals of one another, so then they are not perpendicular to each other. They're also not parallel to each other because they have to have the same number and sign in front of that number. Before we finish or continue, I do need to tell you that there are other forms of linear functions. In fact, there is something called the symmetric form of a linear function, but that will be covered in a separate lesson because there is a particular reason why we use the symmetric form for certain formulas in this course. So finally, just to recap, for a general form equation like 6x minus 8y plus 9 equals 0, just know that you can convert your general forms to standard forms just by isolating your y. If two or more lines have the same slope, they are parallel to each other, and if two lines have slopes that are considered negative reciprocals of one another, these are called perpendicular lines. Thanks for listening.